In this video, I wanted to walk through the brew-debugger extension and show you what it takes to create a debugger in VS Code. It's actually pretty simple because most of the debug client functionality is just built into the IDE. So in our package JSON, we need to specify what things we are contributing to the IDE. So here, there's this contributes element. We're adding 3 languages. So we've done the VM language so far. There are going to be 2 more. So each one of those gets an ID and the file extensions that it's associated with. We can have grammars. I have 3 grammars as well. And we have these syntaxes. This is basically how the syntax highlighting is going to work for these languages. We can contribute menu items. So under the run menu, I add a menu option that is going to debug the editor contents. So it's basically debug this file. It's going to be active when our resource language ID matches the 3 languages that we support. We're also going to add something to the command palette. So that's the toolbar at the top of the file. So the little player debug button that will show up there. In our case, we're just adding a debug button. And again, this is only going to apply to files that are in language we support. And then the command that's tied to both of these menus is this debug editor contents. Here's the definition of the command. So we give it the title, we give it a category. It's enabled when there's not a brew debug session active, and there's an icon for it. We're also contributing breakpoints in these 3 languages. So with this here, the user will be allowed to set breakpoints in those files. And we're contributing a debugger. So we have a debugger called VM. It's going to support all 3 languages. Label is VM debug. In the launch JSON file, we require the attributes project name and port. So project name is the path to the file or folder that we're debugging. Port is by default 8888, but you can change this if you need to. You would also have to change the Java server side, of course. And then stop on entry can be true or false. If this is true, it will stop on the first line of the program as soon as it starts. Otherwise, it will run until we hit a breakpoint. We also are adding a configuration snippet. So here is basically the default launch configuration. So here, I think this comes up when you're editing the launch JSON or creating a new launch JSON for the first time. You can choose this label, VM debug launch, and it will fill in this default launch JSON configuration. So basically launch main VM in the workspace on the default port, stop on entry. We're also going to contribute a view. We'll do this later when we get into the assembly language. This is like a memory dump viewer. So the package JSON says what we're adding, and then we need some code to support that. So there are 2 entry points for a VS Code extension. We have extension TS, which is used when we're running in the normal IDE. And basically all this does is call our activate VM debug when the extension is activated. And then there's the web extension TS, which is used when you're using the web version of the IDE. And in our case, we're going to do exactly the same thing. Just call this activate function. So over here in activate VM debug, you can see where we're actually contributing the elements to the IDE and handling events. So we have my debug type is VM. This activate VM debug is going to be called whenever our extension is first activated. So when, I think that'll happen when someone first focuses a file that matches one of our languages. So it won't happen right away, but it will happen when a VM file is created or edited. I have this set of my sessions. This is the active debug sessions for our debugger. If there is one active, we're going to disable the debug button. We really only want one active at a time. There's a memory view provider. We're going to create that, and we're going to push a subscription. We don't care about this yet. We have a function here to update whether our debug session is active. So this will be called whenever we think that has changed. It's going to do a set context, which will set this variable, and the value will be true if my session size is greater than 0. So basically, this flag will be true when one of our debug sessions is running and false when it's not. And we call it right away to initialize that variable. And then we have these handlers you'll notice pretty much everything is added to this context subscriptions. So anytime you add a handler for something, it's going to return a resource ID or something associated with that observer. And we add it to the context subscription so that when this extension is shut down, all those things can be removed. So when a debug session starts, if the type is our debug type, we're going to add that session to our active sessions. And then we're going to call the update to set the flag to show that there is a session active. When a debug session is terminated, if it's our type, we will delete a session and we'll go update the flag. This could be simpler, but maybe eventually we'll want to allow more than one debug session, and then you would need the set. I don't know. Probably we'll never do that. Here we're registering a command, debug editor contents. So this is the one we saw in the package JSON. And so when the debugger is actually started, this is what's going to happen. We're going to get the resource that's passed in. And if it doesn't exist and there is an active text editor, we will default to using that active text editor. Is not. And then we tell VS Code to start debugging. So here, instead of using launch JSON, these values are all being hard-coded. So when you hit the debug button in a file that's open, it's going to default to these settings. If you want to have more control over that, you need to create a launch JSON and use that to start the debugger. We're going to create a configuration provider and register it, and we're going to create a server descriptor factory and register that. We've got some code commented out here. Later, we might add this in. This will let us hover over variable names in the code and see their values. So this is from the debug extension example, and I haven't yet rewritten it to work for the VM. This custom event, I think, is old code that I probably should delete. I haven't dug into it enough to figure that out yet. Here's some more example code. This will let the inline values feature work. So when you're debugging and you hit a breakpoint, you'll notice in some languages it shows the values of the variables right next to them on the line. So we can implement that later on if we want to. Here's our configuration provider. Basically what happens here is a launch JSON configuration is given to us, and we can fill in extra attributes if we want. So if the user only specified some of them, we can fill in default values for the rest. This doesn't really do that, but if there is no launch JSON, this is going to go ahead and fill in the default values. So if our active text editor is one of the languages that we support, we're going to go and fill in all of the default attributes and set the project name to be that file. And we always set the current working directory. This is used by the debug adapter server. So we do need that to be in there, and that is always getting added by this code whenever debug session is started. And then for our server descriptor factory, we're not going to do anything fancy here. We just call VS Code debug adapter server, and we give it the port that we're going to connect to. And otherwise, this built-in debug adapter thing will work correctly for us. That's pretty much it. The memory view provider we'll look at later on when we're going to use that. Under syntaxes, we have some grammar specifications. This is how the syntax highlighting works in these languages. So in VM lang, no, this is the wrong one. No, this is the right one, I think. I guess I have the wrong extension here. The file type should really be .vm, I think. Anyway, there are patterns for labels, instructions, registers, numbers. This might be a hybrid one that. No, it looks like I just left some garbage in here from whatever example I started on. So anyway, the key is you have these regexes that match things, and then you can associate those with certain constructs in your language. So if we have digits with a colon, that is treated as a label. If we have any of the keywords from our language, right, we've got these VM opcodes, and we're going to be adding more later as we go along. All of those get highlighted as keywords. We have some register names. This really shouldn't be here. Numeric constant, here's a regex for a number, and that will be highlighted as a number. Comments or anything starting with a pound sign, and then strings or anything inside of double quotes. So those are all going to get colored appropriately when we are editing a file in IDE. And then the other languages, Brew, I ripped off from the Java one that is used in the Java extension. This is a giant complicated mess, but it'll give us really good syntax highlighting. And then for the assembler language we'll look at later, there's another grammar for that. So really, there's not a whole lot here, right? Creating a debug extension in VS Code is pretty easy. The part that is a little bit more difficult is creating the debug adapter server.